Hi, everyone. Welcome to the second workshop that I'll be hosting for software skills. Today, we are going to be doing Python and GitHub. And this is the second part to today's meeting. I'm recording this all on Sunday, June 12th from 3 p.m. to 5 p.m. It's already 5 p.m., so I guess I'm taking more time to do this. It's probably going on for another hour or two, but that's all right. This workshop is going to be an accelerated course of going through Python skills and also the advanced topics such as advanced topics such as OpenCV, computer vision, tkinter, object-oriented programming, and Python networking. Now, this is enough material to cover like 2 years worth of coursework, but I'm going to try to go through this in about 1 hour. So unfortunately, I won't get too in depth with some of these, but hopefully you'll get enough understanding of the topic in order to start using it on your own projects and go into more depth of the applications to do so. I have Angie here with me. Actually, Angie, were you able to download Python through Visual Studio Code and begin working through it like that? Okay, cool. I can just skip that. What version of Python do you have, by the way? 3.9. Okay, good enough. Good enough. Good. All right, we're good. So that was like the first prerequisite. Do you have Python downloaded? If you do, great. We can skip past that. If you don't, it's pretty simple. Download Visual Studio Code. Download. I think I already had at the beginning, but download Visual Studio Code. Download a version of Python. I like 3.9 something. In general, Python 3.10 it seems to be a little buggy for me, so I don't like 3.10. Make sure your environments are nicely set up. Make sure you download the Python extension for Visual Studio Code because it's an important thing to do. Make sure you have done, and then you can start using it. So we're going to be using Visual Studio Code to cover some Python concepts, and then go into some of the more advanced topics. That's not normally used. That's not normally covered in an introductory Python course. Now, I apologize if I start stuttering and losing my words and focus in this workshop because I've been going on for 2 hours already. But again, if you have any questions that you'd like to ask during this workshop, please go ahead and do so. I'm open the floor at any times. And so if you're confused on anything, if I haven't explained anything thoroughly, you can always go ahead and speak up and do so. Afterwards, if you're watching this recording, if you would like to listen to me, or if you have any questions, just go ahead and leave them in the Discord. You can always DM me. You can always do all those things. I'm really accessible. So if you guys need anything, I'm here. Okay. So let's go ahead and talk about GitHub first of all. You guys should all have been invited to the GitHub unless you haven't given me your username or your email. In which you haven't done so, please go ahead and do that. Go ahead and go in the Google Classroom and put that in so I can make sure you're accounted for. And the GitHub is going to be the CPP battery vending machine. If you guys are not familiar with GitHub, this is a place to store code. It's kind of like Google Drive, except you can't edit the code on the website. The GitHub repository, battery vending machine, is kind of like in the cloud. It's going to be stored in the cloud area as a reference point for everyone to edit. So if you want to edit this code, what you need to do is you need to download GitHub or use Git. Now, GitHub Desktop is an application that makes things a lot simpler for you to access the code and see changes, make pull requests, and make pushes. Now, I'll describe all those terms in a little bit, but all you need to know is make sure you go ahead and put this repository into your computer. Because in GitHub, what you have is basically a local version of the code and a version you can have on the cloud. So if I go ahead and draw this, you have a cloud version of the code. And then you have a local version on your computer, right? And the local version and the cloud version can communicate between each other. Now, this is a version control in a nutshell because the code base is going to be the same. It's going to have the same files. It's going to have the same pictures. It's going to have the same folders, but your local version may be different from the cloud's version. So if you want to edit the code, you're going to make a pull request from the cloud. So you're going to pull the code into your local version. So you just saw I pulled some edits from Mohammed and Aaron into my computer. And fetch origin is just a fancy term of saying refresh the page. Okay. So if you see a pull from the cloud, you're going to pull it into your local repository. Now, after you make some changes to your local repository, let's say you make changes. Every time you make a change, the GitHub repository is going to detect that. So for example, I'm going to go ahead and do a sample change, and I'm going to go into the test folder and add one file called GitHub tutorial.txt. And in the GitHub tutorial.txt, I'm going to put hello world. Okay, I'm going to save this, and then I'm going to exit. Now, what I just did was I created a file inside GitHub tutorial. I edited the file, hello world, and then I saved it and I closed it. Okay. Now, if I go out to GitHub desktop, you will see it has detected that change. It's saying, hey, wait a minute, this is different than before. You added a text file called GitHub tutorial, and you put hello world inside of it, right? So great, amazing. Now, if I want to update the cloud with this information, what I need to do is I need to make a commit. So then I need to commit my changes. Right? Okay. So when you commit, remember, this is version control. So you might be working with more people, and you will be working with more people. So you need to make sure you say to them what you changed. So make sure you go ahead and always, in fact, this is required. You can't commit without this. Always put a message saying what you changed. The more specific, the better. But you don't need to go all out and write a full essay, right? A lot of interns at like tech companies will do this, and it'll annoy the heck out of senior developers. So instead of talking about circuits, now we're talking about like programming. So diverse skills. So by default, it already has create GitHub tutorial.txt, which is fine. I'm going to do that. So I'm going to say create GitHub tutorial.txt added hello world. And if you want a more detailed description, you can, but again, it's not necessary, right? So I'm going to go ahead and commit this to main. Now, when I commit this to main, what it does is it updates my local repository with the new information. It does not push it to the cloud yet, right? In order for me to push it to the cloud, I have updated my local version, and now I'm going to go ahead and press this button up here, which is push origin, right? So I'm going to go ahead and push origin, and I'm going to push it to the cloud, okay? So after I push to the origin, then we can see on the GitHub here, if I make a refresh, you can see I created GitHub tutorial, I spelled it wrong, and I added hello world, right? So under here, you can see there's a new text file in the cloud, right? We are in the cloud now, and it says hello world. So our changes have been updated to the GitHub. Now, make sure you apply this to your own code, because your own code might be a little bit more different, might be a little more complicated, okay? And Angie and Sandra, since you're here, do you guys both have GitHub downloaded and GitHub desktop downloaded? I would like your help on some of these things that I will be doing, so it'd be great to have it. Angie, go ahead and download the desktop version real quick. We can get back to this in a little bit and test this out after some of the other concepts, but go ahead and download the desktop version so we can go out doing this. And for those of you who are recording in the future, or looking at this recording in the future, go ahead and perform these tasks too, so we can check these and make pull requests and merge conflicts and all of that. Okay, now keep in mind that when you're using GitHub to do version control, you are going to be working with other people. And this is really important. There are going to be many other local computers, many other local computers that are all going to have the same code. They're all going to look at this, and they all have the ability to push and pull, right? So they can all push and pull. And you can see how if you're going to be working in some big company like Google, right, that has like 100,000 employees, 100,000 people writing code and checking code and doing all that jazz, it's going to be really complicated, right, to manage the versions. because every single one of these local computers is making a change. I'm going to make a change. I'm going to push it to the cloud. I'm going to make another change. I'm going to push it to the cloud. And every time there's a change and I push, someone's going to have to review it. And someone's going to have to make sure all the code is in place. It's a really complicated system, right? So how do we compensate for that? Well, let's take one of these local branches, for example. If I want to have multiple things to work on, let's say multiple folders, multiple tasks. Let's say I have someone working on the battery vending machine, and I have someone working on the TK intro UI. I have someone working on the fiducial markers, right? If I store it all in a central cloud database, it's going to get really confusing, right? Which is why we have something called branches. So inside one repository, one can have multiple branches, in which the main branch is usually called main or origin. Okay, so in addition to the main and origin, you can have it split off into multiple branches, maybe one for like BMS code, one for UI, maybe one for servers. So these branches all contain code based on their current version they were created, right? So from this tree here, I created the base code and the UI and the servers based off the origin code. Now let's say the UI team has made significant progress and are ready to push back to the origin, right? So I'm going to push back to the origin. And now I'm going to update the main code. So now the origin is located here. When the other subteams may have to merge back to the main code, there's going to be some conflicts because some code may have changed. The base code wants to go out to the origin, and the servers may have to go out to the origin. This is called integration. Okay, and so when this happens, something may happen called a merge conflict. Some code is going to look different than others, and you're going to have to manually go in and change that eventually. But the main point here is seeing that branches is a good way of separating code into different folders and different tasks. So what I'm going to do here in Github repository is I'm going to go ahead and create a new branch. Okay, so to create a new branch, all you got to do is to click on here, click on the current branch main, and then click on new branch. I'm going to call this GitHub test. Okay, and now everyone that's watching this, I want you to go ahead and do this current action. Do not create a GitHub test, but access the GitHub test branch. You should be able to do this by pulling the necessary information from the cloud. Again, each local version of the code is going to have its own branches, because the branches are inside the repository, and each local folder has its own version of the repository from the cloud. Okay, so branch. Okay, so everyone go into GitHub test. Okay, and then I would like you to open the folder in the Explorer window. Okay, after you open the folder in the Explorer window, go to test, go to GitHub tutorial, open it, and then contributors. Is it E? Is it? Yeah. So I'm going to write this contributors, and I'm going to put my name here. I'm going to save this. I'm going to exit this. Okay, and then I'm going to exit this window. Now you can see in the edits that it says I have added contributors and then my name down below. What I want you to do is I want you to pull this this repository. So I'm going to publish this branch here, and then I'm going to say added name to GitHub test branch in GitHub tutorial.txt. Also, oh yeah, there is a restriction. It says that great commit summaries contain fewer than 50 characters. Sure. It doesn't matter for this example. So I want you guys to practice committing, and I want you guys to practice pushing it to origin. Okay. When you've done so, you can go back and check that your commits have gone through, that your changes have been made. So if you go back to the GitHub tutorial.txt, if you go back to the main branch, right? You go back to the main branch, you can see that it says here that GitHub test had recent pushes less than a minute ago. So under the main branch, if I go to test and I go to GitHub tutorial.txt, you see that, hey, wait, my changes aren't here. I added my name to GitHub tutorial.txt, but it's not here. So where is it? If I change the branch from main to GitHub test, we can see that my changes are here. They're located in a different version, like an alternate universe of this branch. So my contributions are now in the GitHub test branch, which is Christopher Lai. You can see down here, it's in the folder. So that's great. And after this video, if you guys are watching, I want you to add your name to the contributors, and I want you to do it inside GitHub test. So I want you to do this in GitHub test because I want you to practice doing a pull request. So what a pull request is let's say I want to move it back to the main topic. So I want to bring it back to the origin, like here, right? Everything eventually has to go back to the origin. Everything has to eventually go back to a main part of the code, like the primary part of the code, right? So in order to do this, we go over to the pull request branch. And if you guys ever get a tech internship in the future, in which I highly suggest you do, because this will be a lot of fun. This is like the entryway into like the real world, like how to make a real pull request. So I'm going to go ahead and compare and pull request because this was my own change. And it says that I'm going to open the pull request and I want to move my code from GitHub test into main, right? It says this is able to merge. And this line here says I'm adding my name to GitHub test branch in GitHub tutorial.txt. And I'm going to go ahead and press create pull request, okay? Now, GitHub will automatically check to see if this is able to be pulled successfully, automatically. So it's really smart. Like if it's possible, if there's no like conflicting code, it's going to automatically do this for you, all right? Now, I want to bring up an important point here. In a group project, if you're doing this with a project manager, always check for the review. Do not pull request yourself, right? This is already opened and you want to get someone else to review it before you actually push this, right? Just in case you're going to merge conflict, you're going to conflict with another branch. So for example, let's say you're working on the TK Inter UI and you want to merge your code with the origin, but also the BMS code is conflicting. What you do is you ask for review from the BMS team and the project manager and some other people that might know what's going on across the entire board. So go ahead and request a review from, let's say, I'm going to request it from Bethany because she's part of the logistics team. And I'm also going to request from Michael, who has not given me his username. So I'm just going to request it from Bethany. And then when Bethany has reviewed it, she is going to go ahead and merge the pull request, right? She is going to say, okay, that's fine. Like nothing's wrong. And she's going to go ahead and click merge pull request. I'm pretend I'm Bethany here, right? So merge pull request, confirm merge, and pull request successfully merged and closed. The GitHub test branch can be safely deleted. So usually once the test branch, the information has been properly merged with the main one, it can be deleted. So it doesn't need to be existing anymore. However, just for the purpose of this test experiment, I would like you guys to make an edit to the GitHub test branch, upload it and push your code, and actually try to pull request to the main branch. And remember, add a reviewer. It can be me, it can be Bethany, it can be Michael, it can be Angie, it can be whoever. Just get someone to review it, make sure it is valid, and then go ahead and merge it. Why do I have so many tests? Oh my goodness. Oh my goodness. My Discord is popping off. I guess the physics 1520 server has been rejuvenated. It just like pinged me like 20 times in there. Okay, anyways, so back to the main point. When you guys watch this video, go ahead and make your own pull request and try to ask a reviewer and try to make it back into the main branch here inside the code window. And you'll know your code works when you go ahead and click the test, click GitHub tutorial, and you can see the contributors in the main branch. Okay. Are there any questions on that? Are there any questions on how GitHub works? We'll get into merge conflicts later when it pops up. But in general, this is like how you should upload code, right? You should upload it not to the main branch, but into a separate branch you create. So for example, if you're in the BMS team, you're going to upload it into a BMS branch. If you're on the UI team, you're going to upload it into a UI branch. Same for the servers branch. The reason we do this is because we always want a stable version of the code inside the main branch. If someone is coming by our CPP battery vending machine repository, we want to say, hey, look what we have. And the main branch is going to pop up first. That's going to be the working version of our code, right? So they're going to go ahead and download the main branch, and then they're going to go ahead and work with it. Unfortunately, if we have something that is work in progress, we want to communicate between other team members. That's why we need the separate branches to do so. So always, always, always create a separate branch to work in your code. Never upload to a main code. You always want to make sure code reaches the main branch through a pull request. And always make sure you tag someone like me to review the code before you upload it to main, or else disastrous things might happen. Like, you may be able to destroy the entire team's code, and I may have to like go back and like revoke it if you don't check with other people first. Because if you're just focusing on like one assignment on one task, you may not be aware of like what the other teams are doing, but the project manager will. So just word of warning, that's what you're supposed to do, even if you're in a bigger project in the future, right? And so Angie, Sandra, if you get your GitHub tutorial working, just go ahead and practice this, try uploading the code to GitHub and trying to look at it on the actual website. Okay, so we have talked about GitHub for version control. Next, we're going to be talking about some Python fundamentals. Let me go ahead and open up the GitHub repository, and I'm actually going to do what I'm saying, and I'm going to make a new branch called Python Workshop. Okay, this branch is going to be based on the main branch. I'm going to say create, and then I'm going to go ahead and publish the branch. All right, so after I publish the branch, I'm going to go ahead and go into Explore, and then I can go ahead and start editing the files here. Now I'm going to teach you guys a neat trick. Okay, so if I want to run any Python scripts from like the command prompt, or activate something from a command prompt, which is just a shell of the actual kernel that this is running on, I can just type CMD here. And if I type CMD, this pops up, which is a command prompt. And inside the command prompt, if I type in the thing, if I type in the command code space dot, it will automatically create a Visual Studio Code workspace for me based on the current repository that I'm in. Alternatively, if you would not like to do that, GitHub Desktop also has an option to open the repository in your external editor, which you can just click this button, open in Visual Studio Code, and you can see it does the exact same thing. I now have a Visual Studio Code workspace just for my battery vending machine, right? So under test, I'm going to go ahead and create a workshop files folder. And here is where I'm going to be coding some of the things that I'm going to be teaching you today. So under workshop files, I'm going to go ahead and create a intro.py script in which I'm going to like just rapid fire go through all the concepts you need to like understand in Python. So really quickly, the first thing you should know how to do is you should know how to do print statements. So print statements like print hello world is probably the most basic output statement you can have. And of course, when you're dealing with Python, make sure you have the correct version in the bottom. I have Python 3.9.7, which I think is my favorite. You can have your own. But once you have your Python extension ready to go, go ahead and click the play button on the top right corner of the screen. It opens a Windows PowerShell and it activates the script and it says hello world. Okay, so print statements are really cool. You can just do print hello world. Let's say print hi. This is Chris. That self-explanatory. Print statements are great for troubleshooting. They're great for knowing where you messed up in your code, and they're great for just like saying things in your code that you don't want to say in the user interface. So great for backends, right? Next, we're going to go with basic arithmetic and variable storage. So variables are basic storage components in your code that is stored in the memory, and you can assign them different things to to store. So in Python specifically, you can be very versatile with it. Declaring a variable is as simple as just writing a name. So you can say my variable like here and set the equal sign after, and then this is immediate other variable. So my var, it can be an integer. It can be, so my var can be 5, right? It can be an integer, but it can also be a double, like 2.2. Let's say my var 1, my var 2 is 2.2. It can be a string. So my var 3 is a string, like string right here. My var 4, it can be a Boolean, so like true. In Python, your Booleans are either capitalized true or capitalized false, like true here or false here. All right. And you can also have like you can also set my var 5 into like a storage element, like an array or a list. So like this is a list here. A list can store multiple data types like Booleans, strings, and integers and data types, and even objects if you go into object-oriented programming. So that's a list. You can also have a dictionary as well. So my var 6 would be a dictionary, like let's say you have like 0 and then like a list in the middle. Let's say like 5, 6, 7. And then you have another element like 1, and this is like hi. Oops. So that's a dictionary, which is a very versatile storage element, similar to like a linked list if you learn in C++, and similar to that as well. So those are data types, pretty basic. Moving on to if statements. So if statements are conditionals. So if you have something like a, let's say my var equals 3, right? Let's say if my var is greater than 5, I'm going to go ahead and print hi. Else, I'm going to print by. Okay, so whatever you put inside the conditional statement here, and you don't need parentheses. Python is very versatile. You can literally just have if my var is greater than 5, like that. It's saying if this statement is true, then I'm going to print hi. Otherwise, I'm going to print by, right? So my var equals 3. If 3 is greater than 5, which it's not going to print hi. It's going to skip to print by. So this piece of code should just print by, like that. And if I change this my var to be greater than 5, and be like 8.7, right? Then it's going to say hi, right? So that's an if statement in a nutshell. You put something in the conditional window, and you can have greater than symbols, less than symbols, equal symbols. If you have an equal symbol, though, make sure it's equals equals, or else it's going to think it's like a variable assignment, and that's not good. So if it's an equals equals, you can just do my var equals 5, and there you go. Bam, hi, right? You can also have Boolean algebra, so like my var equals 5, or my var 2 equals 3. So we can have something like this: my var equals 3. So if either one of these are true, then it'll activate, right? Let's say this is 4. Then you'll see if I do plus symbol here, you'll have hi, because my var equals 5, which is true, but my var 2 equals 3 is false. So at least one of them is true, which prints hi. Okay, if you want to have ands, you can also do so like this. And it's a comparison between those two ones, but it's not true, so it prints by. Moving on to functions. Function calls are really interesting. In Python, you can call functions using the keyword def, and then your function name like YOLO, and then any parameters that you pass in. So like, let's say I want to pass in an integer called hi1 and hi2, right? And that's your function definition. And inside your function, if you don't have anything, you don't want to put anything in, you write pass, right? And to call a function inside your code, all you do is you say YOLO, and then you pass in like two numbers, let's say 3 and 4, okay? Now functions have return types. You can actually return stuff from functions, or you can just like call them and have them run code. So for example, I just want to say answer equals hi1 plus hi2. This function, all it does is it adds two numbers, right? And if I print the answer, if I print the answer here, I'm going to get 7, because the code sees the def keyword and actually skips it. So it just defines this function first and then runs it at the bottom. So YOLO 3, 4, it'll call the YOLO, it'll pass 3 into high 1, 4 into high 2, set the answer equal to high 1 plus I2, and print the answer, which is 7, right? Now, let's say I want to return this function. Let's say I want to create a new variable, my var1 is equal to YOLO34, and I want to store the result of that function inside my var1. So what I do then is I say return answer. I'm going to take whatever is generated inside this function and spit it out into whatever variable is being assigned to. So I'm going to say my var1 is equal to YOLO34, and if I print my var1, I will get 7, all right? So that's how you can reference functions a lot and return things with them. Okay, in the essence of not going too in depth, I'm going to go over one last topic. Whenever you write Python files, you'll see that indentation really matters. There's no semicolons, and you can actually just really free flow your writing. However, in good Python writing, you actually need to have something called an if name equals main. I believe this is what it is. Hold on, let me just check my reference to see this is correct. If name is not a string, but if name is equal to main. So this is just checking within the within the command prompt shell itself, verifying the file is actually what it is called. It's like saying, does the file exist? Is the file named after itself? And then if it's true, then I'm going to go ahead and call a function called main. Now in C++ or C#, you might have a main function. This is usually how it's done, but in Python, you don't have it, so you have to create it yourself. And this is more stable in doing so because it limits the scope of your variables. So hello world, like that. So when you call this, it separates, like let's say if you have to import some library, so like you import math, like that, or import random. If you import a library, it separates it from the rest of your code because your main code that's being run is inside the main function. So it's kind of like an isolation measure just to make sure your code is more organized. And I like using this because in case you have a separate function in your code you'd like to test, you can just like always change the main function to that. All right. Okay. That's all I'm going to cover for the intro section for Python fundamentals. Angie, Sandra, you got any questions on that? Nope. All right. Again, if you're watching this recording and you'd like to ask me a question, you can do so. But let's go ahead and move on to the next topic. Okay, the next topic we're going to cover is OpenCV and computer vision. So if you're not familiar with this, basically what we're doing is we're going to be activating our webcams and analyzing objects inside frames. So the basic concept here is we're going to take a frame out of a video stream, analyze it, and then spit it back out. So computer vision is really great for identifying things like different colors in an image, different objects. There are extreme algorithms out there using TensorFlow and YOLO that also have will also provide you with understanding of like, is an object like a microphone, for example, or is a calculator, or is a person. So very specific things that they can identify, and that's using some machine learning algorithm that we may or may not cover in this internship. However, in any case, the simplest way to go about doing computer vision is getting some OpenCV code into your computer, having it open your webcam, having it get the video frames from it, and then you can apply filters to those frames. A camera frame is simply just an array of numbers telling you what the RGB value is at all times. So let's say I have a camera frame here. And usually these camera frames are like, let's say 680 by, 640 by 480. So what's in the frame? Each pixel in the frame, right? Each pixel has an RGB value, right? Each RGB value, and there are a total of 640 by 480 RGB values in the entire square, right? So what OpenCV does is it takes that frame from your camera, it turns it into an NP array of all the RGB values found in your image, and it takes it and stores it inside a variable. Now you can imagine how fast this must happen in order to get a consistent video stream out. So for example, if I want to put the FPS counter on a video stream, it has to literally take each frame, put it into a variable, and then change the variable to add that to the frame. That's how video editing is performed, by the way. So I'm just going to change a few of these RGB values. Let's say I'm going to make the center one yellow, and then maybe this one over here green. I can do that in post, right? If I just edit this NP array after it has been stored in a variable, then I can do whatever I want to it, right? I can even identify objects. I can take this and I say, hey, if I have a bunch of green pixels around this orange pixel, around this yellow pixel, then I'm going to isolate it and I'm going to identify it, right? And that's the basis of looking at objects. And in this project, we're actually looking at fiducial markers, which is a specific type of Aruco code. We're going to be looking at Aruco codes, which is a specific variant of fiducial markers. And a fiducial marker is basically a marker in a camera in which it can be used to position things around, because those markers are always going to be a specific size, shape, and ID. So because it's consistent in an image, we can isolate that as a variable when positioning things around the frame. So let's go ahead and do some really simple code first and teach you guys how to set this up, because there's a few things that need to be done before you can actually start using this. Okay, so go ahead and open up your Visual Studio Code again. Let me just go ahead and clear this. And I'm going to go ahead and make a new file called cv2.setup.py. So we are going to be using the OpenCV library, which is a dependency. And a dependency, or a library, if some might call it, is basically a collection of functions that you can use in order to run some code. And so here I'm going to go ahead and inside the command prompt, I am going to run the command pip install, and pip is a package installer. So pip install opencv-contrib-python equals 4.5.3.56. Okay, so now the reason I download this is because opencv-contrib.python is the upgraded version, which has more functions and more vision algorithms to detect things. And the correct version in which it works is 4.5.3.56. Now, true story, one summer day last summer, I went ahead and spent literally the entire day trying to download this, because the current version is around like 84 or something like that. But the current version, if you just download it without the version control, it's going to try to build the entire folder inside your computer. And these are called wheels, right? If your wheels aren't built, you can't drive a car. In this case, if your wheels aren't built, you're going to have to like try to install them on your computer, which takes a long time, and uses CMake, uses all these different building algorithms from C# that will basically take up your entire day, and it might not even work. So if you downgrade to a previous version that already has its exe built, then you can actually just start using it really quickly. And I already have this downloaded, so it won't do anything on my part, but for you guys it might. Which is a good life lesson for other applications such as Windows 11. So, or like the new iOS version. So you don't upgrade to the new iOS version instantly, because it may have bugs and may actually cause your experience using the program to be even worse than before. Okay, so now to go into some basic CV2 stuff, let's go ahead and open a camera. I'm going to go ahead and import numpy as NP. Again, remember the camera frame needs to be stored in an NP array consisting of RGB values. And I'm also going to import CV2, which is the OpenCV library. I'm going to import imutils, which is a lot of utilities for the OpenCV library. And I'm also going to import time. Again, we're going to go ahead and try to put the FPS counter on the screen, like I said in the previous thing. But first, we're going to display a camera stream, a live camera stream onto our window. So the first thing we're going to do is we're going to define our camera used. So define the webcam that is used. In most cases, we're going to do set a webcam object. So a webcam object equal to cv2.videoCapture. And this video capture is going to find the first thing that is on our computer, which is going to be the first webcam. Now, this is going to be accessing a specific COM port on our computer. So when you plug in your webcam to your computer, or if your webcam is already inside your computer through a laptop, it's actually accessed through a little wire called the COM port. And so 0 is going to find the first COM port that has relations to a webcam, in which this is going to be 0. And that's why I actually didn't turn on my camera for this section, because I'm going to have to use the same camera for OpenCV. So we're going to go ahead and do cv2.videoCapture. Now, this is a function that automatically sets the webcam object inside webcam for us. So it's going to be 0, and then I'm going to use this isolation chamber called cv2.cap.dshow. Okay, this just makes sure that when you're trying to access the camera, that doesn't say it as a false positive and completely skip it. Now, this part is extremely important, and this is actually one of the scripts that I've developed in the previous year for compatibility reasons. So in this section, we're going to check for compatibility. If the camera does not exist, we need to force search webcam. Okay. In some computers, the 0th index is actually not where the webcam is stored. It's actually stored in like ID4, some weird place like that. So in order for us to see if there's actually something on the webcam at a certain instance, we're going to go ahead and determine our ret frame, and we're going to read a frame from the current webcam. We're going to try to do this. Now, I'm going to encapsulate this in a try-catch block. Try-catch blocks are great for finding out errors and other things like that. So I'm going to try to see if frame equals none. Right? If that's the case, then I'm going to set the webcam equal to cv2.videoCapture, and my argument is going to be -1. Now, if frame equals none, that means there's nothing coming out of the webcam. A none object is kind of like if you just have nothing there, obviously. Then it's going to set the webcam to a new object, and it's going to have a -1 index. This -1 index inside the video capture CV2 library is pretty much just a forced search. So it's going to search through like all of the different COM ports to see which one works, right? Now, if this even fails, if frame is not equal to none, which means it works, then we're going to, and it's going to throw an error because it can't read from that. So I'm going to go ahead and put an exception here. I'm just going to say pass, so nothing's going to happen. Okay. Now, once we have a successful webcam up and running, then we're going to write the while loop. So while true, so this is always going to run. We want to get a consistent frame of information or a consistent process of information from our webcam. So all we do is we do the same thing. So we grab a frame from the webcam using this function, and then we're going to show the frame. So cv2.imshow is the function that will show it in a separate window. So I'm going to call this window test, and I'm going to take my frame object and I'm going to display it. And I'm going to add something here. So if cv2.wait key 1. So if I press a key, then and 0xff. So if I press a key and the key is just so happen to equal q, then I'm going to break, right? And then my code is going to end. And then finally, I'm going to go ahead and destroy the window after there's nothing else coming through the webcam. Okay. So again, what does this code do? all this code does is it tries to find a webcam, and then it tries to display the frames coming through the webcam. Because remember, a video is pretty much just a bunch of frames played in order, right? If you're watching like an old style Disney animation film, it's just a lot of images played in a sequence. So that's what this is basically. And then if we press Q, it's going to break and release. Let me try running this. Okay, cool. So it has found my webcam and it's displaying my window here, and it's pretty smooth. I mean, it's literally just taking the data from the webcam and then processing it and plugging it into a window. So if this works on your side, that's great. If it doesn't work, then let me know what error message you got. We can troubleshoot. But for the base information, the base layer, we have a webcam, we have a frame, we have a processed image. You can see me. That's great. Okay. Now we're going to take this up a notch, and we are going to apply some filters to this frame. And so this is kind of like Snapchat filters, but in this case, we're going to add like different filters to allow for the code to start identifying different objects. So in the event, in the end, I want this code to identify different contours on my face. So we're going to use something called the adaptive threshold algorithm. Okay. So the first step in applying the adaptive threshold algorithm is turning every single pixel to black and white, because black and white is easier to process compared to RGB. There's less data to find. So I'm going to create a new variable called grayscale. And this grayscale is going to have cv2.cvt color frame cvt.color bgr to gray. So this function will just take our frame and will convert to grayscale, right? Next, we're going to apply a Gaussian blur to our frame. So I'm going to say cv2.Gaussian blur and grayscale. I'm going to do this Gaussian blur with a 9:9 blur factor. I'm going to say this is a 0. Now, Gaussian blur, what this does is it smooths out the pixels from one pixel to another, so that if we have a grayed out image and we have a Gaussian blur, then all of the contours would stick out because they would be the intersection of all the pixels blurred across each other, right? So then what I'm going to do is I'm going to make the adaptive threshold algorithm based on the blur. So threshold equals cv2.adaptive threshold. Right? I'm going to take in the blur object. I'm going to say my max value is 255, so it's an 8-bit value at that. And I'm going to apply the cv2.adaptive threshold Gaussian C algorithm, and also the cv2.thresh binary algorithm. Thresh binary inverted algorithm. And then I'm going to say my block size is 23, and the ID is 3. Okay, so what have we done here? So we have went ahead and took our frame, and we passed the grayscale filter through it, a blur filter through it, and a threshold filter through it. Now let's see what this looks like. So I'm going to go ahead and show a different window, right? I'm going to show my frame window, which is the default. I'm going to say the modified. I'm going to change this to grayscale. Okay, when I play, you're going to see two windows pop up, right? One is going to be a window of just like the regular frame, and the other window is going to be a frame of the grayed image. Now, I don't know how smooth this looks on your end, but in my end, it's really smooth. Right, so you can see a lot of the colors, like the whale I have back there is bright blue, but in the grayscale, it's like just a black and white color. So it's less data to process for a black and white image compared to a regular color image. So it's better for processing image, because remember, this happens like 24 times a second. There's a lot of computing power. A lot of computing power from the one hand. Okay. Okay. Now I want to show you guys what the blur looks like. You guys saw what the grayscale looks like. Now you guys should see what the blur looks like. It's really fun experimenting through all these computer vision algorithms here. Okay, So it's like taking your glasses off, kind of. So like my glasses are not as refined. Everything looks kind of blurry, but in fact, this is really good for adaptive threshold because it can tell like whether something is a contour or not, or whether it's a sharp line or not. So our last algorithm I want to show you guys is the adaptive threshold. So let me go ahead and get out from the screen. I do Control C to get out, but you can also press Q. All right. So the last one is threshold. Okay, so now we've applied the actual algorithm. The threshold is based on the blur, and the blur is based off the grayscale, and the grayscale is based off the frame. And you can see that there are a lot of differences here, right? The main difference is you can see that all the contours are whited out, and all the ones that are the same are black. So it tries to estimate where all the contours are. This is really important because it allows us to figure out like what objects are in the frame. So if I have like a solid object, like the back of this calculator here, you'll see it's a very black, and then it has a white contour around it. So we can identify that and isolate it from the frame, right? If I have this like a little pin here, right? You can isolate this. It seems like it's saying that it's a lot of white because of the glare, but it's just like a one solid object. Like my iPad, for example, right? That's one solid object. It's really black. So now the real question is, how do I draw lines around this, and how do I identify it from the screen? So that's what we're going to do next. We're going to take the threshold object, and we are going to find all the contours inside this object here. So find contours. We're going to create a variable called CNTS, which is a contour object. And I'm going to say cv2.findContours. Again, like all of these functions are already inside the CV2 library. It's just up to you to determine what it is. We're going to pass the threshold frame. And then I'm going to use the cv2.ret r_external algorithm to find this, and also cv2.chain approx simple. Okay, now I'm going to take the contours because right now the CNTS is going to be a huge list of things. I'm going to say this is equal to CNTS 0 if length of CNTS is equal to 2, else CNTS is going to be a list of 1. So this just isolates it in case that it finds no contour. So it's like pitch black, or if there's no object, it doesn't just crash and die. So now for all of the objects in the CNTS, so all of the contours that it finds, it's going to say my area. The area of these contours is going to be cv2.contour area, and it's going to take this in it. So this for loop is a special for loop in Python, which is based on objects in the list, right? So I'm going to find the area of each of these contours, and if the area is larger than 10, for example, I'm going to say cv2.drawContours. So it's actually going to draw this on the screen, contours, and I'm going to draw on the main frame. So on the frame, I'm going to have the frame object, the item that it's going to look at, -1, and then I'm going to draw this using the color greenish, I think. So it's going to be RGB, so 36,255,12, and then an ID of 1. Okay. So after we do this, the frame object should have been changed, and also the threshold object should have been changed as well. But this is going to only limit the contours greater than 10 pixels to be shown on the screen. Let's go ahead and save this code and run. Okay, so now we have basically isolated all the white objects, and we have drawn green lines around it. So we can see that it's being shown, and it looks actually really cool. And if we want even less contours to be shown, and maybe the more prominent ones to be shown, we can go ahead and increase this number from 10 to like 100. So like only the contours of 100 pixels or bigger will be shown now. Let's try it out. Nothing much seems to have changed. You can see like more of the contours on my face are defined, and more of the printer outlines, like over here. This printer is like really well defined. There's a big old contour around it, and the door seems to be really nicely defined too. Let's just amp it up to like 1000. See if there's any contours like 1000 size. Okay, so there's even less contours now, which is great because it only shows the ones that actually matter. So like maybe that printer back there, my door, maybe the big mirror, right? Some of the more defining factors of the image. Okay, so that is pretty much what you can use computer vision for. Now it depends on what you want to, what applications this is for. So I've just shown you like the basic information about how to display a window and how to go about writing some basic code for it. But you know, you can go ahead and do this with your own task as well. I do want to show you guys one thing though. I'm going to create another script called cv2.faceDetect. Just one application of OpenCV. I'm just going to paste some code here. This uses the hard cascade frontal face default algorithm, which is a data set based on machine learning that identifies faces inside a screen. And it does it because it's already a built application. So it's a pretty simple one at that. It doesn't use any complex power or TensorFlow or anything. All it does is it goes ahead and tries to find a face inside the image. So if it doesn't see a face, it will just like not display the square. Otherwise, it will. And it'll also display the position of the object inside the frame as well, right? So if I move my face over here, you can see like it detects that, like over here. Pretty simple. So if you want to build your own data sets using like images, you can, but you also got to like train your model. This XML file has already like the trained models inside it, so it doesn't need to, you know, do another calculation of like a neural network in PyTorch or something to do so. And you can see that this XML file just like consists of a lot of different object of pixels that are like really close to next to each other. And so if that resembles a face, it will go ahead and identify that and display it in the image. And you can see the frames per second is around 30. So I'll upload this as part of the Github tutorial for today. And you can use that with your own code if you'd like. I don't know if there's any facial detections necessary, but you know, all the better. Okay, are there any questions for the computer vision section of this tutorial? All right, if not, we're going to move into the next section. And the next section is, the next section is tkinter and object-oriented programming. Great. Okay, so I'm going to go ahead and accelerate through this code, for example, code right here. I'm only going to point out the important parts. I'm going to make a new one called tkinter. Example.py. Now I derived this from another piece of code of mine, but I'm just gonna paste this entire thing here. And if you have any questions about this, let me know afterwards because we are running a little bit out of time. So tkinter is a dependency in Python in which you can basically create a user interface. So you can create buttons, you can create labels, you can import pictures, you can import windows, and it's really nice and really cool. So here you define your variables like the height, width, refresh rate of your tkinter window, and then you have to initialize it using these functions right here. Inside tkinter, things are arranged based on canvases, and you can create a main canvas like this, and you can bind other canvases to the main canvas through this function. But the main important part is how to create labels and buttons. So here is the class label. I think Sandra, I told you about this yesterday, but this is how I can, for example, really easily automate the process of creating different labels. So for example, I have here some IMU labels, I have some board temperature labels, some battery voltage current capacity labels. This is just a generic one. And if I run this code, you can see that everything is just like zeroed out for that for now. But everything follows the same it follows the same example of system 0, gyrometer 0, accelerometer 0, magnetometer 0, and it has the label, it has the units, and it has the actual data and information, right? So that is how you can actually display this data, right? I can actually call this class and say what I want in it. So I want accelerometer data x, error, and meter per second squared inside the accelerometer x variable. And I can do the same thing for each of the other ones then. So these are the unit labels that are being created. Now, if you want to change the value of the actual label, you're going to have to do it in what's called an update function. Now, this update function is recursive. So every time you run this function, and this is just basically drawing from a simple database of all zeros, which is called nums. Every time this function runs, and again, remember we had a refresh rate of 50 milliseconds, so it's going to update every 50 milliseconds. Every time this function runs, it's going to update the value of the label using this accessor here of this class. And it's going to assign it with a new variable from a num0. So in case you want to change this outside the scope, like a global variable and change the numbers, you can do that. And then you can see it changed in the update data function. And of course, make sure you go ahead and call it at least once outside the update function to start for the first time and actually create the new window using root.main loop. Okay, are there any quick questions about this file? You can use this file and kind of reverse engineer it to base it off of for your own UI. But this is something that I just used for a lot of other projects I wanted to share with you guys to show you what it looks like in the long run. You can also create buttons on the bottom for like exit buttons and stuff like that too. It's really versatile. Okay. Well, it's currently 6 p.m. I've got another meeting to head out to. But as always, if you guys have any questions in the future, or if you're watching this recording, I encourage you to ask me and or ask the team and work together to find the answer, because the fun of engineering projects is always to find the answer, right? Okay. But if there's nothing else, I did not cover servers today. That's the only thing I did not cover. I may cover it in a future workshop because Python networking is pretty important as well. But that's something for the future. Maybe next week I'll touch upon it a little bit. Well, thank you so much for watching today, and thank you for coming. For those of you who are on Zoom, I know this is like it's been such a long long workshop so far, and we went over so many things. But I'm glad we did. To give everyone in this internship a good understanding of different skills. So without further ado, I'm going to start heading out. But thank you so much for watching. I wish you have a great rest of your day, whether it's today on Sunday or some other time in the future. But yeah, so just thank you. Have a great day, and I hope to see you later. Bye for now.